Point 4, trig identities. Let's just do a recap of everything that we've learned over the last few lessons on trig identities. We have in previous lessons discussed how trig functions can either be even or odd, and that's what you see here in numbers 1 through 6. Depending on where you are on the unit circle, let's say that we have this point xy, or as we have now been used to seeing, this is really like cosine theta comma sine theta, given that you have some triangle with some angle theta there, right? And, based on finding the negative value of that angle, we know that positive is going in the counterclockwise direction. That's your positive angle theta. But if you go in the negative for angle theta, then, you'll actually be placed here in quadrant 4. And exactly how does that change things? Well, we know that we develop another triangle here, and what you can see here is that this ordered pair is more along the lines of cosine theta comma negative sine theta. So you can see here that we get that negative y value. And so that's what we see with sine of negative theta, you end up getting that value is actually going to be a negative sine of theta. So one thing we've established in previous lessons is that sine is an odd function given that particular property. Likewise, its reciprocal, cosecant of negative theta, also has the same characteristics. So this is the same thing as negative cosecant of theta as well. It's an odd function. Number 2, cosine of negative theta. We know that the cosine, which represents the x value here, notice how it has the same x value regardless of whether you have a positive or a negative angle measure. And so therefore, cosine negative theta still gives you that same x value or still gives you cosine of theta. And so we know that that's going to be an even function. And likewise, its reciprocal, secant of theta, will also be an even function. Number 3, we know that tangent of negative theta is really the same as sine of negative theta over cosine of negative theta. So if you establish that sine is an odd function and cosine is an even function, then we know that odd over even, it will become an odd function still. So this still gives us a negative tangent of theta. So tangent is an odd function, and so is its reciprocal. Moving on to another property that we have discussed in the past. If we look at the unit circle, we know that on the unit circle, since it's a unit circle, there's a radius of 1. And, this has the point x comma y. So in terms of the unit circle equation, we could say that x squared plus y squared equals 1. In the past, we've also realized how, in terms of a particular angle measure, let's call it theta, that the x value is really representative of cosine of theta, and the y value is really representative of sine theta. So therefore, when replacing x and y with the appropriate trig functions, in the past we have seen how we can get this new trig identity, sine squared plus cosine squared equals 1. From that one property, we can get 2 more identities. Recall that we have been able to take our sine squared plus cosine squared equation, and we can modify it simply by dividing, let's say, by cosine squared theta. And if you divide everything by cosine squared theta, you end up getting a new trig property, where this becomes tangent squared, this becomes 1, and this becomes secant squared theta, and that gave us our second trig identity. Another trig identity that we had developed in the past was seeing how you don't just have to divide by cosine squared, you could also divide by sine squared. And so if you divide by sine squared theta, then you end up getting 1 plus tangent squared theta is equal to, and then that becomes a cosecant squared theta. So that gave us our third trig identity. And these are the 3 identities that you want to have memorized. These are good to definitely have in the back of your head so you can just recall them at a moment's notice. Okay. All right, let's go on to the next identities here that we see. It says, what relationship do you see between sine and cosine in the first quadrant? Okay, based on that trig chart that you had developed before, I'll just draw a very simplistic version of it. One thing that you had seen was, let's say you had the 30 degrees, the 45 degrees, and the 60 degrees. And then you also had the sine, the cosine, and the tangent. And one thing that we had discussed before was exactly what is that relationship that we see between the 30, 45, and 60 degrees, specifically with the sine and cosines. I think one thing that hopefully we have established already is that there is definitely a pattern among sine and cosine. How if you think about sine of 30 degrees, it's really the equivalent value of cosine of 60 degrees. And likewise, you can flip it around. You can say that sine of 60 degrees is the same as cosine of 30 degrees. And even you can establish that sine of 45 degrees gives you cosine of 45 degrees as well. Okay, so with those particular characteristics, now what comes to mind is, what if it weren't those unit circle properties? What if we said sine of 20 degrees? Then what would you say? That would be equivalent to cosine of what, right? And so, the idea here is, can you find that pattern that establishes how can we get sine and cosine to have some kind of relationship here? And so hopefully, I'm trying to give you some time to think about this. Sine of 20 degrees, that's equal to cosine of something. And hopefully what you're coming to mind here is cosine of 70 degrees. If I were to say sine of, let's say, 40 degrees, then you would say that that is the same as cosine of, Okay, hopefully you have in your head, you're thinking, oh, that's 50 degrees. The idea being that if you have sine of theta degrees, it's really the same thing as cosine of 90 degrees minus theta degrees. Okay, so you have this idea where it's really just the complement of the other trig function. Okay, so similarly, if you want to go between cosine and sine, then cosine theta is the same thing as sine of 90 degrees minus theta. And it turns out that this really works for its reciprocal functions as well. So cosecant of theta is equal to secant of 90 degrees minus theta as well. Secant is the same thing as cosecant of 90 minus theta. They have that relationship there. Tangent also works the same way. It's equal to cotangent of 90 minus theta. And cotangent is the same thing as tangent of 90 minus theta. Okay, so these are known basically because they work hand in hand together. These are known as the co-function relationships. Okay, so these are going to be the identities and properties all on this page right here. These are going to be what you're going to be using when simplifying or proving trig expressions. Okay.